All right, so this format that we're going to put everything in that looks like this is called Vertex Form. All right, and what we did before when it was just x squared plus x plus some number, call it c. Um, this is called standard form. So this is what we've been doing all our graphing in. And what I just showed you on Desmos is that it's a lot easier to graph when it's in vertex form. You already know where the vertex is going to be, and you know if it's going to be opening up or down, depending if this is positive or negative. Right? So we can always do the long way and plug in 7 points and figure out how to graph it. But if this is the format, it's a lot easier. Okay? So let's go ahead and just go through a few of these together. So for each of these, it says it wants the vertex. Okay. It also wants the axis of symmetry, which is part of the vertex, and which direction is opening. Okay. So the vertex here is going to be a where. Right. So remember, it's the opposite of whatever this is. So this is positive 2, so it's going to be at negative 2. And then that's always the same, minus 3. So remember how much work it was just to figure out this point before, but when it's in this format, I already know this is at negative 2 comma negative 3. Okay. And the axis of symmetry, that's going to be x equals whatever this value is right here. Okay. Those are always the same. Go ahead and highlight those, keep them. They'll always match. Do you guys remember what symmetry means? What that word means? Symmetry means like it's reflection. So what it's saying is that x equals negative 2, x equals negative 2 is a vertical line. It's saying that this middle right here at negative 2, x equals negative 2, you're going to have half the graph on one side, half the graph on the other, and they're going to be a reflection of each other. That's what that means. Oh, is this going to open up or down? And how can you tell? Yeah, this is positive, so positive. So direction is going to be positive, so it's going to open up. If that was negative, we'd say it's going to open down. All right. So far so good, right? There's no mathematics, arithmetic calculations here. It's just looking at the equation and pulling out information we need. Opposite sign, same sign, vertex. The axis is the same as the x-coordinate of the vertex. Those are always matching. And then we're looking in the front here, seeing if that's positive or negative for the direction. We haven't done any calculations yet. Okay. Next, I am going to plug in an easy number to work with. I always suggest 0. So plug in 0 here, and what would you get? What would you get if you plugged in 0? So 0 plus 2 is 2. 2 squared is 4 minus 3 is 1. So when I plug in 0, I'm going to get a y of 1. So 0 comma 1. So what I just did is I found the y-intercept. Plugged in x equals 0, and I found out this calculation equals 1, So I know x is 0, y equals 1, so that's the point 0, 1, also known as the y-intercept. And since we have this axis of symmetry, here's the nice thing. I know on the other side that's also a point because it's a mirror image. So if I get this side, I get this side for free. And that's it. That's all you're going to do for your graphing. Go ahead and connect it. Draw a parabola. If we wanted a more accurate parabola, we can plug in more points, but that's pretty accurate for our purposes. We know where the vertex is, we have the y-intercept, and we have this other point we get for free because it's a mirror image using the axis of symmetry. Now, if you take out all the explanations and all the talking, this comes down to about 30, 45 seconds. Much, much faster than everything we did before. Okay. Let's do a few more just on this side. Let's do the vertex for a few of them just to make sure we got it. Let's go down to here. What's the vertex here? On number 3?
3 and -2.
Is that 3, -2? Is that right? Oh, what's wrong with this? Yeah, the x part is always the opposite. So if this is a +3, that's the vertex is actually negative. Same thing up here. This was +2, but it was at negative. Okay. And again, why is that true? Right here. See, when I make this positive, where does the vertex go? It goes to the negative side. Anytime this is a plus, it's actually on the negative side, -10. This is +10. The vertex is at -10. Okay. All right. The axis is what? X equals what? Yeah. So going back to your example, I said these two are always the same. Okay. It's like saying where's the middle of the graph? -3. So far I have this, -3, -2, -3, -2, and I know the middle of the graph, the axis, is right here. And the direction? Okay. What's the sign in the front? That's positive. The sign is positive, therefore it opens up once again. Yeah, if there is no sign, it's automatically a positive. So basically you're looking for a negative sign. If there's not a negative there, it's positive. If there's a negative there, then we know it's negative, then it'll be down instead of up. And lastly, let's find the y-intercept. Let's see here. Plug in 0, right? So plug in x equals 0, see what you get. 7? Okay, so y equals 0 plus 3 squared minus 2, which equals 9 minus 2, which is 7. So I know this is the coordinate 0, +7. My x is 0, so y equals 7, 0, 7. So that's up here. What do we get on the other side for free? 1, 2. Now notice how it's 3 away from the axis. 1, 2, 3. So I can go 3 away the other direction. 1, 2, 3. Get that free point and go ahead and graph the line. There we go. Now there will come a point where you won't have the y-intercept, but for now you will have on all of them. All right, you guys go ahead and work on the rest of the front. I want you guys to have the front all 6 done by tomorrow. Just the front. We'll work on the back tomorrow and Thursday. And Friday finish up the video, maybe have a quiz. Okay? Go for it.